Let us begin the topic of probability with revision of some of the basic terminology. See, first we have what is called as a random experiment. That is, an experiment is nothing but certain phenomena. Say for example, tossing of a fair coin or throwing of a die. That is called as an experiment. Now each run or each execution of an experiment is called as a trial. So that means if we think of tossing of a coin as an experiment, then one toss is nothing but one trial. So if we toss it once again, then that second toss is the second trial, and so on. Now each trial of an experiment will result into some outcome of the experiment. So taking once again the example of tossing of a coin, you know that it can result in any of the two outcomes that we call as heads or tails. Now the set of all such possible outcomes of a random experiment is called as the sample space, as we know. So it is written in a way we write a set. And lastly, an event is nothing but any subset of the sample space, right? So these are the basic definitions of probability. Now we move on to what is called as the classical definition of probability. That is, as we know, the probability is nothing but the likelihood, or in day-to-day language we call it as a chance of occurrence of certain event. So here it is denoted as P of E, that is probability of event E is nothing but N of E upon N of S. So that means it is number of outcomes which are favorable to the event E, which is denoted by N of E, divided by number of total outcomes in the sample space. So it's basically nothing but the ratio of favorable outcomes to all the possible total number of outcomes. Okay. Now this definition is applicable only for certain types of experiments, that is where we can have different countable outcomes of an experiment. Say for example, tossing of a coin or throwing a die, or some examples based on playing cards and so on. So there are situations in real life where this particular definition does not apply. That is, if we consider, say, what is the probability that it will rain today? So such kind of question cannot be answered by a simplistic formula that we are having here. Alright, so therefore this is called as the classical definition of probability. Now moving ahead, let us see what is called as the axiomatic approach to probability. That means, as we have seen here the limitation of classical definition, let us see the most general and axiomatic way to define the probability. Now here we will see three fundamental axioms related to probability. As you know, axiom is nothing but a statement which is taken to be true for granted, because it is such a fundamental and basic idea. So first is, for a sample space S, probability of any event E is a real number such that probability of E is always greater than or equal to 0. Secondly, probability of sample space is equal to 1. And third, if E1, E2, E3 and so on up to En are mutually exclusive events. Now here mutually exclusive means that if you take any two of these N events, then they will be nothing but totally disjoint events. That is, there is no outcome common to those two events. So we may take any such pair out of all these N events, and we should have all those pairs as disjoint sets. So in that case we call these events as mutually exclusive events. So if this is the case, then probability of union of all the events, and here union means just addition of all the events, that is in set theoretic notation it is the union. So that union is equal to P of E1 plus P of E2 plus P of E3 and so on up to P of En. So what does this third axiom tells? That for mutually exclusive events, probability of union of all events should be equal to sum of all the individual probabilities. Now based on these axioms, we have certain deductions. That is, at the end here we are seeing that from these three it follows that probability of E lies between 0 and 1. So it is not only just positive, but it lies between 0 and 1. And also probability of a null set, that is probability of an event which does not have any outcome, that is equal to 0.